Welcome to Technically You, where the tech gets explained without the jargon. Today's episode is all about one of the unsung heroes of web security, the Web Application Firewall, or WAF.
Yeah, if you've ever wondered how websites defend themselves against attacks like SQL injection, cross-site scripting, or even bot traffic, WAFs are the silent gatekeepers.
So let's start at square one. What is a WAF exactly?
A web application firewall is a security solution that filters, monitors, and blocks HTTP and HTTPS traffic to and from a web application. It sits between the user and the web server, analyzing every incoming request.
I think of it as a bouncer at the front door of your website, checking every visitor and filtering out the troublemakers. So how does a WAF work?
WAFs use a set of rules called policies to detect and block malicious traffic. These rules can catch things like is-ill injection attempt, cross-site scripting XSS, cookie poisoning, and file inclusion attacks.
All right, so now that we've covered what a WAF does, let's talk about how it actually detects bad traffic. There are three core detection methods modern WAFs rely on: signature-based behavioral analysis and machine learning.
Yeah, think of these like three different pairs of glasses your WAF wears to spot shady behavior, and they each serve a different purpose.
Let's start with the classic signature-based detection. This method uses a known list of attack patterns or signatures, kinda like a blacklist.
Right. If someone sends in a payload with union select from users, a classic SQL injection attack, the WAF recognizes that exact pattern and blocks it immediately.
The good part? It's fast and reliable for known threats. But that's also the downside. If the attack is new or cleverly obfuscated, signature-based detection might miss it.
Which brings us to behavioral-based detection. This one is more adaptive. It monitors normal user behavior and flags anything that doesn't match that pattern.
So if your website usually gets login attempts every few minutes and suddenly you get 300 in 1 second from the same IP, that's a red flag. That's likely a brute force attack.
Exactly. It's like your WAF is going, wait, that's not normal. I'm going to raise a digital eyebrow.
But this method needs time to learn what normal is, so it's more prone to false positives, especially during startup.
And then we've got the new kid on the block, machine learning. This one is like behavioral detection on digital steroids.
With machine learning, the WAF analyzes massive amounts of data across thousands of users, apps, and environments to learn what threats look like, even if they've never been seen before.
So instead of matching a pattern, it recognizes the intent. Like, hey, this request feels malicious because it's probing a ton of endpoints rapidly in weird sequences.
And the cool part, the more data it sees, the smarter it gets. Some next-gen WAFs are now using ML models that update daily, sometimes hourly.
To sum it up, signature-based is your fast first layer for known attack. Behavioral is great for anomaly detection, and machine learning brings predictive power into the mix.
And the best WAFs today use all three layered like a cybersecurity sandwich. That way you're covered, whether it's a known threat, a new exploit, or just weird behavior.
Also, some WAFs operate in block mode, immediately stopping malicious requests, and others work in monitoring mode, letting admins see what's going on before taking action.
Now, let's talk about the different flavors of WAFs.
Okay, there are three main types: network-based WAFs, deployed on hardware appliances for high performance; host-based WAFs, integrated directly into the app's software stack; cloud-based WAFs, hosted by third-party providers, easily scalable and cost-effective.
Cloud WAFs are becoming really popular, especially with services like AWS WAF, Cloudflare, and Azure Application Gateway. What does a WAF protect against?
WAFs defend against OWASP top 10 web application threats. That includes injecting attacks, broken authentication, sensitive data exposure, XML external entity, XXE, and more.
Basically, if there's a way a hacker could mess with your forms, cookies, or URLs, a WAF can stand in the way.
All right, techies. How do you actually set one of these up?
It depends on your WAF type. For cloud-based, you usually just configure it via dashboard and apply rule sets. For host-based, you might integrate it with your web server like Apache or Nginx.
WAFs also support custom rules, so you can block specific IP'd, enforce geofencing, or rate limit traffic from abusive sources.
Let's hit the benefits. Real-time threat mitigation, regulatory compliance like PCI DSS, DDoS attack prevention, application layer security, and less stress on devs patching code.
And let's not forget, WAFs provide visibility into attack attempts, so you can learn and adapt your defenses.
No tool is perfect, though. What can a WAF do?
Great question. WAFs can't stop every 0 day, may struggle with encrypted payloads, can be bypassed with evasion techniques if misconfigured, might produce false positives.
So, it's a strong layer, but not your only line of defense.
Absolutely. Now, who should use a WAF? Well, if you host a website, app, or online service that handles user data, logins, or transactions, a WAF is for you.
And e-commerce, SaaS, healthcare, fintech, any sector with customer-facing web apps should have one. What about the future of WAFs?
WAFs are evolving with AI, real-time analytics, and cloud-native integration. We're seeing more zero-trust integration and smarter behavioral analysis.
And with APIs on the rise, API security gateways are becoming the WAFs of tomorrow.
All right, folks, that's your podcast on web application firewalls. They're smart, strong, and crucial in the war against cyber threats.
If you liked this episode, subscribe, share, and stay tuned for more digital defense demystified right here on Technically You, and remember to always stay curious.